Wonderful. So first of all, make sure everybody in the group's name is on the quiz. So I give you all credit for it. Because we're going to get 10s on this, I'm imagining. I imagine, right? So let's make sure, first of all, we understood what the quiz was asking you to do. Because it's basically just a recap of grade, which I want to take one step further this week. I want to have this lead us into measuring large things without having to, say, climb those large things. And that'll take us right into other kinds of measurements and data analysis, which will start probably next week. So first off, make sure you got your quiz in front of you. Why did I have you take 5 different measures on your staircase? I think one group couldn't do 5, right? I think there was only 4 steps in the one set of stairs. I could be wrong about that. You guys, 3 steps.
Pretty much.
That's pretty much, was one crumbling so bad you couldn't. It was 4.
For the run, there was only 3.
Gotcha. One was gone, essentially. Good. That's totally fine. Why do 5, or why do multiple? Why not just measure one of the stairs and go, that's good?
Well, because they all varied in measurement. They weren't all the same.
Yeah, depending on how precise your measurement is, which is something that this class pretty much ignores. Actually, almost all classes ignore what's called precision, except for chemistry classes. Yeah. If you guys take chemistry classes, you do quite a bit of interesting mathematics in chemistry. You do dimensional analysis, you do precision, you do error propagation, very interesting, error propagation, fun stuff. So yeah, there is some variance from stairs to stairs, even though when they pour these things, they generally cut them with pretty good precision. I mean, I would imagine they're off by no more than a couple 1/16ths of an inch. But I mean, at least the forms are. But then when you actually create, when things move and expand and kind of settle in, you get some variance. And I mean, measure any house. Go into a house with a framing square and stick it into a corner and see how 90 degrees it is. Chances are you might have a degree or 2 of wiggle room in there. When I was building that door, I had to because the damn opening wasn't square. I made the top and bottom square, but because the wood that was running this way was cast off wood from a building site, it was all kinds of bowed. So, I mean, you've got issues. Sometimes it's more important than others, like, for example, if you're flying a rocket in outer space, it becomes a huge issue. But for things like stairs, if you're off by a 1/16th or 2, not the end of the world, right? Not the end of the world. So I had you take 5 to kind of wash out and get at the idea of an average. So you guys have 5 grades, yes? Did you write your grades in percent or decimal form? Decimal? All? Both. That's totally fine. So let me hear some stairs and their average grade. So we've got stairs, and then their average grades. Average grades. So call out your set of stairs. Go ahead. Wait, Michelle.
Our average we got an average for the rise and the rise. What do we do?
Oh, so in order to do your average grade, you averaged the rises, averaged the runs, and then did the ratio of those 2.
That's as far as we had gotten, and then we came back.
Oh, okay, so what I would need you to do is just take, it'll be close enough in this case, just divide the average rise by the average run and give me that result. Okay, give me another set of stairs, please.
We have K.
Step K. What was your average grade?
0.372.
0.372, not 0.0372.
No.
0.372. Which is what as a percent? 37.2%. Tell me what that means. Again, tell me what it means to have a 0.372 or a 37.2% grade. Tell me what that means. Tell me what that means. Tell me your name again, too.
Ian.
Ian, thank you. Go.
Every 100 feet, you rise 37 feet.
Every 100 feet of run, for every 100 feet of run, you rise 37.2 feet. Now, of course, this is a stair, which maybe, what were your guys' run? Tell me your name again.
Pete.
Pete, and this is Ian and Pete. Tell me what your guys' run was on your stair generally. What was your average?
On average, it was 5 1/4. Or sorry, our run was on average 14.
14 inches, and you got about a 5-inch rise.
Yeah.
So if you extended this angle out, the angle even mentioned it, if you extended this grade out to 100 feet of run, it would have to rise 37.2 feet. Hopefully that makes some sense to you guys. By road standards, steep, shallow. By road comparison. Remember on Wednesday we were comparing it to roads around Bend. Insanely steep. This is roughly, I believe, the grade of that road in Pittsburgh. Remember the one with the cyclocross guy going up it? I think that's the kind of the grade of that road, which looks like a cliff if you're standing at the top of it looking down at it. This would be a pretty serious, like a high blue, maybe low black diamond run at Bachelor. which again, it doesn't seem that bad until you're standing at the top of it looking down at a mile of it. When it's 14 inches at a time, not a big deal. Not a big deal. It's also the avalanche zone. You're getting into the avalanche zone for snow at this point. You're starting to tip up into where snow will slough off and create slab avalanches. And if it gets too steep, it generally doesn't hold long enough, but you're getting into that danger zone for those of you guys that go into the backcountry snowboarding and skiing. You gotta be careful about. This is why it's helpful to carry a clinometer, which is a way to measure angles in the backcountry. Put on your ski pole, tilt it up, measure the angle, and be like, holy crap, it's 39 degrees. It dumped snow yesterday, and it was, well, anyway, get into a different class there. But anyway, this is pretty darn steep. You guys, your task right now, find the angle that corresponds to that grade. We'll come back to it, okay? Find the angle using the tangent tables. Give me another set of stairs. Michelle, go ahead. B. What was your average grade?
The grade was .578.
.578. 57.8%. Oh, I forgot to ask you guys. Pete, where were your stairs? Where were stairs, K? Ish.
Outside of Ochoco, right?
Outside Ochoco? Okay.
Yeah, Ochoco.
Outside Ochoco. And Michelle, you guys were?
Inside of Grandview.
Inside, right, the only set of inside stairs, right when you walk into Grandview Hall, that first set there. 57.8%, which means for every 100 feet of run, you rise 57.8 per 100, per percent. Steep? Insanely steep. You don't see roads like this. You are now out of the avalanche zone if you're backcountry skiing, because snow doesn't hold to slopes like that. Generally speaking, avalanche snow won't hold to it. You guys, you are tasked with finding the angle that your stairs form, using tangent tables. We'll come back to that momentarily. Kelly, what do you guys got?
G.
Stairs, G, where were they?
Just right before Ochoco.
Right before Ochoco. Awesome, sir. What was it? What was your average grade?
54.8%.
54.8%. Another very, very steep set of stairs. There's one set of stairs I want to add to this activity. It's inside
Lovely.
Ochoco. Inside, you know the stairs? Yes. Inside Ochoco Hall. You can
I was actually just thinking
here.
about that too.
I think it's the steepest stairs on campus, I'm fairly sure. It's right by room 123. If you've been inside Ochoco, there's a big lecture hall in Ochoco with a very steep set of stairs itself, or steep set of seats itself. The stairs, it's about 8 steps right next to that. Insanely steep. Insanely steep. Very, very nice. 54.8 degrees. 54.8 degrees. Stairs G. Who had, oh thank you. You're good, you're good. Who had the set of stairs out by Pence? You guys find the angle too.
28.5.
Oh, beasts. We'll come back to that. How did he get 28.5? We'll come back and make sure we can answer that. Set of stairs that are outside Pence, I call them the knee breakers, because they're very, very like this, and then they drop like that, which basically forces you to always be stepping down with the same foot. I call those you guys. Give me your letter.
I.
Steps I. What was your average grade? What was your average grade?
Oh, the average grade,
Yeah.
13.17.
13.17. Look at the. Oops, too many zeros. 13.17. Look at the difference in the grade there, friends. It's
No,
steep.
that was just, that wasn't percent, that was just.
Why?
Oh, yeah,
0.1317,
okay,
13.17. So look at the difference in grade. It's still steep by road standards. It's still steep by road standards. If you, it's twice the steepness if you measure it with grade as College Way. College Way 6. So this is going to rise twice as much as College Way. But compared to other stairs on campus, it's not as much. Does anybody know what the code is for like inside stairs? Does anybody know that off the top of their head? I don't. Okay, it's one of those weird questions I should look up to see what code has to be. It probably has to be within 2 grades or something like that, within a certain pitch. That's what it's called. So what you now have is you've got these different grades of exterior and interior stairs. The question I then had for you guys is, what's the angle formed by these? What was the angle? I didn't put this on the quiz, I don't think, anywhere. It doesn't say what the angle is. But tell me your name one more time.
Allie.
Allie, thank you.
It's between 20 and 21.
And how'd you get those numbers?
The tangent chart.
Right, don't forget, if you ever need to turn a grade into an angle, which is going to come in handy on Wednesday when we go back outside again and measure some trees. If you ever want to turn a grade into an angle, you need a conversion, and the table is probably the easiest way for us to do that. So all I do is I get in there and I Google tangent table like I did